So in this video we are going to study how to graph and shade a linear inequality. We've already done a lot of work this school year on graphing linear equations, graphing a line. So we're going to start by recalling some of this prerequisite material, which is how to graph a line. Most importantly, we need our equation in slope-intercept form. That's what we spent a lot of time working on, which means we need it solved for y. Y equals mx plus b. We've done that a lot first semester, we've done that a lot so far second semester, so let's go through and review this rather quickly. I need to get y by itself, subtract 2x from both sides of my equation to maintain that balance. 5y is all that's left as my 2x cancels on the left. These are not like terms, I can't combine them. Negative 2x, the 20 is positive, so plus 20. Y is not by itself yet, so I have to divide by 5, and I will do that to every term, not just one thing. My 5's cancel. Y is equal to, leave this as a fraction, but simplify it if we need to. This doesn't simplify, so I get negative 2/5 x plus 4. I now have my equation in slope-intercept form. I can pick out my slope, and I can pick out my y-intercept. The slope's the number we're multiplying x by. That's negative 2/5. The y-intercept is the constant at the end. Since it's a positive 4, we write our y-intercept as 0, 4. Now, one further thing to review about slope, make sure we remember it's always rise over run. So if my slope has a negative 2 in my numerator, that means I'd go down 2. Positive 5 in my denominator means I'd go to the right 5. So just to kind of summarize that, if the number in your numerator is positive, that means you move up. If it's negative, that means you move down. So it's vertical change in your numerator. The denominator is your horizontal change. If the number in the denominator is positive, you move to the right. And if the number in your denominator is negative, you move to the left. You will always start by plotting your y-intercept, and then from there you apply the slope from up here. So that's what we did first semester, was graphing lines. Now we're not graphing lines, though. We're not going to have an equal sign. We have these inequality symbols. And remember that if we're graphing on a number line, these symbols mean that I have an open circle on a number line, or that my solution starts here but not included. Compare that to my greater than or equal to, less than or equal to is when we graphed it with a closed circle, meaning my solution starts here and includes this value. So we have to be able to differentiate that on a coordinate plane as well, but we're not going to use open and closed circles. Instead, we're going to use dashed lines and solid lines, meaning if I have an equation, for example, that's y is less than 2x plus 1, I'm going to graph that with a dashed line. This symbol is going to tell me to do a dashed line. Or if I have y is greater than 2x plus 1, either way, it's going to be a dashed line. In this case, I would graph it this way as my dashed line. Whereas if my line had the or equal to, so y is less than or equal to 2x plus 1, or y is greater than or equal to 2x plus 1, that's graphed with a solid line. I'm not going to dash it. That's how I differentiate. So it's the same idea as open circle, closed circle. We can't open a line, so to open it, we dash it. Now, you would think that these are the same things, but because it's an inequality, my solution's not just on the line here, or my solution's nowhere here yet. The solution is going to come in the area that we shade, and that's what we have to compare these symbols. So solid line, because they both have the line under it, but I would shade on different sides of this line based on the symbol, whether it's a less than or equal to, greater than or equal to. One of the tools we'll need to do that is to be able to determine if a point is a solution. So to do that, we choose a point. Typically, we're going to choose 0, 0. That's going to be the best point to choose. And when we're choosing that point, we're choosing it because we want to now plug these values in. This is telling me my x is 0 and my y is 0. Plug those values in and see if it's a solution to that inequality. So in the first semester, if this was an equation, I'd say, is this point realistic? Does it make sense with that equation? Same idea here. I'm checking, is 0 less than or equal to 2 times 0 minus 3? Is 0 less than or equal to 2 times 0 is 0. 0 minus 3 is negative 3. If you look at it, and now positives and negatives and zeros are going to be confusing, think of it on a number line, or draw yourself a number line. Here's my 0, my negative 3 is over here. Is 0 less than negative 3? No, because the further to the right the number is, the bigger it is. So this is not true, which means this is not a solution. Which is important because if we're graphing the linear inequality, that means I can't shade on the same side of my line as that point 0, 0. I'd have to shade on the opposite side of that line. And we'll do that here momentarily. This second example is similar, but now I'm checking x equals 3 and y equals negative 1. So I plug negative 1 in for y. Is negative 1 greater than negative 2/3 times x, which is now 3, plus 4? So is negative 1 greater than, put this in our calculator, fractions go in with parentheses. I get negative 2 when I multiply this. Negative 2 plus 4 is 2. Well, here's my negative 1, here's my 2. Is my negative 1 greater than 2? No, it's not further to the right. Is 0 less than? Saying is 0 further to the left of negative 3? No. Both of these are examples of not being a solution. So that's the background skills that we're going to need to be able to do. We're going to need to be able to solve an equation for y, or an inequality in this case, recognize whether my line is solid or dashed, and then decide which side of my line to shade. And we're going to do that partially by checking if a point is a solution to the inequality. On the back of our notes today, we have two examples that we're going to go through. In both examples, they're already in slope-intercept form, so I already have y equals mx plus b, which is fine. It means I can pull out my slope right away. My slope is 2. If I write my slope as a fraction, it's 2 over 1. My y-intercept, b, is negative 5. I write that as an ordered pair, 0, negative 5. Now I look at my symbol. The symbol is going to be what tells me solid or dashed, a greater than or equal to symbol, because of the or equal to. That's my solid line. That's where we fill this in. Dashed is when it's greater than or less than, not an or equal to. That's all the prerequisite information we need. We need to know that before we start graphing, because when I connect my line now, I need to know whether it's going to be connected as a solid line or a dashed line. I graph the exact same way I did first semester. Plot 0, negative 5. That's always begin on your y-axis. My slope is 2 over 1. 2 is positive, that's up 2. 1 is positive, that's right 2. Positive and positive. Plot as many of the points that fit on the coordinate plane I give you. We don't want to stop. Now, that's all the way up, but remember, there's a pattern. Now, if I went down 2, left 1, down 2, left 1, I have this whole pattern, which I could also continue to put points down at the bottom. It's a solid line that we saw. So I would, with a straight edge, connect these as a solid line and put arrows on the end. Now that would have been, if this was an equation, we'd be done, but it's not an equation, it's an inequality. So we're not done. Now, quick general rule of thumb. A general rule of thumb states, and I can flip back to the other side to kind of help us with this. So this is generally. This symbol greater than this symbol, greater than or equal to. Generally, as long as we have put our equations in slope-intercept form, these two equations are going to mean that I will shade, I'll put that in quotes, above my line. And that this symbol or this symbol, less than or equal to, will generally mean shade below. Looking at this example, it's a greater than or equal to. Greater than generally means to shade above, but we can't trust that always. Above means if I start at the very top of my page and I drop a drop of water and it falls, it's going to hit the line at some point. When it hits the line, it's hitting the top, it's hitting above. So this would be considered above my line. Above my line. Okay, this side is below my line. Now, how can I verify where I shade? Pick a point. We think it's going to be above. Pick a point above. 0, 0 is the easiest point to use. Because if I check 0, 0 and plug it into my inequality here being y is greater than or equal to 2x minus 5, plug 0, 0 in, I get 0 is greater than or equal to 2 times 0 minus 5. Or 0 is greater than or equal to negative 5. I have another tool at my disposal here. 0 greater than negative 5. Here's a negative 5. Here's my 0. Is 0 bigger? It sure is. So you can use this to help you compare your inequalities as well. Because we know this is true, we know for sure now this is accurate. I will shade this above. To shade above, take your pencil very lightly. I don't want you to color. This isn't coloring things in, but it is coloring things in with respect to don't cross the line. Above my line is on the left-hand side here. This is above. I'm going to shade in this section above my line all the way across. You're going to do it very lightly. Now you're representing that any point over here in that shaded region is a solution. Any point not is not a solution. That's the representation we're giving. Let's try one more and then we're going to have a lot of practice time in class. Again, it's in slope-intercept form. So my slope is negative 2/3. My y-intercept is 0, 3. This symbol now is no line under it. This is going to be a dashed line. So I will begin at 0, 3, and I will apply my slope. Now, negative 2/3 is negative 2 over 3, or 2 over negative 3. It is not negative 2 over negative 3. If they're both negative, that would make this positive. That won't work. So I could go down to right 3, down to right 3, and continue this pattern until I run out of room, and then reverse it. I made a mistake there. Down to right 3, down to right 3, and then reverse it up and left, up and left, up and left. But this time I'm going to shade or graph this as a dashed line. So when I get my straight edge out, I'm not going to go straight through and draw my line. I'm going to go straight through and dash my line. I'm now representing these points are not part of the solution. Using my shortcut method, I see that this is a less than I should think below. A below means if I drop this, remember if I drop the little piece of droplet of water from here, it's going to hit the top. That's above. Below is on the other side. This is below. This is below. That's where I'm going to wind up shading here. And again, lightly shade in below based on this symbol. To check if it's a solution, pick a point there, just to verify we got this right. 0, 0 is in that shaded area. If I check 0, 0, this should be a solution. When I plug in 0, 0, I get 0 is less than negative 2/3 times 0 plus 3. and that's true.